Hello everybody. I'm going to talk about how to convert Java and Kotlin to Haxe and then target everywhere. So I'm Carlos Ballesteros Velasco. My nick is Soywith, and I'm a tech lead at akamon.com, and I'm the responsible for our framework and the technology of the front end and the game client at our workplace. Also, I have created several Haxe live libraries, and I have contributed to the IntelliJ Haxe plugin. And right now I don't have that many time. So the story, we have a stack like this, and in the game client, we started using Director a lot of years ago, and then started to use Flash. And something like 3 years ago, I suggested to start using Haxe, but nobody listened. So we are still using Flash. And also we have PHP and Java for some tools. So right now, Flash is dying, this time for real, and I suggested again to use Haxe in the front end. I started to migrate our framework to Haxe, but the backend people didn't want it to switch because of the tooling. Also, we wanted to share code and knowledge if it was possible. And then Kotlin appeared. It allows to migrate Java to Kotlin in just one click, and it has bidirectional interoperability with Java, and it's a modern language. Yeah, and it has awesome tooling because it's from the people that created IntelliJ. So we tried several available options to use Kotlin in order to be able to target everywhere, but we had no luck. So I started JTRansc as a crazy holiday spike, and we ended using it. So what is JTRansc exactly? It's a transcompiler that converts TeaVM bytecode into plain Haxe and let Haxe do its magic. Initially, I was not targeting Haxe, so the initial prototype was something like this. It used the TeaVM bytecode, and JTRansc transformed it into a fully featured AST. And there was a feature stripper that allows to reduce the features of the AST and generates a simplified AST without the unsupported features of the target languages. So, for example, JavaScript doesn't support labeled break. It doesn't support Goto, so the feature striper eliminates that. So, as I said, targets are not required to know how to handle all the features, and new features just requires a feature stripper. It's not mandatory to optimize every target to use that feature. So a Goto stripper will convert jumps or Gotos into while and switch, or try to reconstruct if else, whiles, and so on. So cool, but Haxe already targets everywhere. So I was investing time where I should not. And I started to focus on Haxe. So the current implementation looks like this. From a JVM language that converts to JVM bytecode, and JTRansc just converts it to Haxe. It's still AST and feature-based, but the only supported target right now is Haxe. And because Haxe doesn't support Goto, it tries to reload it, generating ifs, else, whiles, and so. So why should you care? Why should anyone to program to JVM? Because now there is Kotlin, it has lots of Java libraries and has a very mature tooling, and it also has Maven, Gradle that are similar to Haxe. And also in our case, we have a huge code base, so we can reduce that. And it doesn't have preprocessor or macros, so it allows to refactor stuff safely. And why I target Haxe? Because it has 11 years of multiple targets. It has a very small runtime. It's fast, flexible, and it has preprocessor and macros that it's pretty handy for targeting everywhere. So I looked for alternatives to JTRansc, and any of these alternatives allow us to target everywhere. So we would have ending using several options instead of just one. And right now there is no RoboVM is not available anymore, so JTRansc can. We also needed reflection stuff. We have the dependency injection serialization. So JTRansc is okay for that. So the intended workflow, at least for games, in our case, we have a main for JVM. In that main, we inject a specific JVM implementation, and we have another main with JTRansc and Haxe. And we are injecting JTRansc specific dependencies there. So the idea is that our code can run in the JVM, but also on JTRansc. So we always have an implementation for JVM using one interface and multiple implementation, or with one class with annotation that allows to inject Haxe code. And we right now are debugging using JVM. Also, we have to avoid single-threaded. We have to avoid have multiple threads in order to target JavaScript, Flash, and so on. So, how to use it? We can use Maven, and it's a plugin, and then we just call a Maven package. So, an example. Here we have, this is Kotlin, and we have here two mains, one for JVM using GDX, and other using JTRansc. So we would test it just with normal JVM, and with Kotlin, with JTRansc, we would call maybe in package. So it generates, it converts JVM code to Haxe, and then it's generating JavaScript and Flash. So we have it on Flash too. So, there is a library called JTRansc RT. That's a provisional name, but it's a library that you can use without JTRansc. It has annotations that JTRansc understand, and has some utility classes that are optimized to use with JTRansc. So these are the annotations. Some of them are Haxe specific, and others are generic. This is, for example, a class that can be found at the JTRansc RT core, and it provides a default implementation for Java. This is a map that is optimized for integer keys, and it works on Java, but it has Haxe method body annotations, and instead of using this body, when targeting with JTRansc, it uses this body. Here we can add also members to the class, and indicate that this annotation allows to avoid generating reflection information. Also, you can use this annotation to specify a Haxe specific target. So, for example, this class allows to use memory bytecode from the Flash target, and provides a default Java implementation that uses Java Neo, and an implementation for all the Haxe targets, and an implementation that for Flash. So it works like this. So the generated code looks like this. It has names has a suffix with the method parameters and return value, because Java has allows several overloads for methods, so we have to distinguish them, and it generates if-else preprocessor chains, and looks like this. So this is what I said. Packages are converted to lowercase, class names are capitalized, and I have appending an underscore to all the names to avoid class collisions. For example, since math class is a top-level class, you cannot fully qualify it, and in order to with that, I appended that. And also, Haxe keywords are appended with an underscore. Also, JTRansc support to minimize names, packages, classes, methods, to reduce the output size and obfuscate JavaScript code. And reflection also works in this mode. But that means that generating names are not predictable. So I created a mini template engine that looks like Twig. And with these tags, you can reference in Haxe body annotations, classes, methods, and fields, and it will work. So, for example, this is a class to handle WebSockets that uses a library I did. It is on Haxlib. And it has callbacks, and in order to call, in this case, Kotlin methods, I'm using this code to reference to those methods. Also, JTRansc support custom Haxe frameworks and tools. Right now, we are using Lime. Initially, JTRansc had it hard-coded because it requires a project XML file. But now, Minitemplates allow to use any other Haxe framework in the command line, like K, NME, NME, and so on. We have a project that is JTRansc Media that provides a simple interface for multimedia games, and it has two backends, one using libgdx for the TeaVM and other using Lime. And it's a good example about how to use JTRansc with custom Haxe game frameworks. In order to support it, it has several annotations. For example, there is an annotation to include Haxe files instead of just adding Haxe method body annotations. You can just include Haxe files. We can define subtargets, and in this case, Lime requires that the entry point extends a class, so we can define a custom main. And here, instead of calling Haxe, we can define several commands to execute in the build phase. And we can include Haxe libraries like this. and the project file. So in those files that you include, you can use Minitemplates. So in this case, I'm calling Lime, and I'm referencing the subtarget. I'm detecting whether it is a release or debug build. And also I can call other commands, just separating with this. And in this case, I'm generating an iOS application. And the same goes for the command line. I can iterate over flags, defines, and so on. So that's it. It works if your code ends referencing this class. Everything works. So you just call Maven package, and it installs all the required Haxlib libraries, and generate the files and compiles your application. Also, there is another library that is libgdx backend. libgdx is a game library for the JVM, and right now it can run games without modification. Some of them, at least. Okay. So, furthermore to Haxe method body, we can call Haxe directly. There is an annotation called native class that allows you to declare a class as a native Haxe class. So it allows it converts automatically between some types. For example, byte array is converted into Haxe IO bytes and input stream into Haxe IO input, and allows to create custom conversions. So this is the input stream, and here you define how to convert between Haxe and Java, and including a Haxe file, you can create classes. So JTRansc is able to compile itself. So there is JTRansc running on Node.js, and also it is able to load external libraries using JNI. So this is an example that includes kernel and user window classes and calls them. This works on Java. You can execute it on IntelliJ because it's using JNI API. And it is converted to C++ and Node. It also allows you to embed C code. You can use the same tricks you use on Haxe. There is Haxe method that allows you to include code in those positions. So right now I'm working on size and speed of optimizations, and I'm working also in an IntelliJ debugger. So you will be able to debug the output directly in IntelliJ. And the future, I will continue with optimizations. I will investigate SIMD, workers, Haxe abstracts, struct access, and other alternatives to GC, and I will support completely Java8. So, examples. This is a libgdx example that completely works without modifications. Okay. So in this case, some days ago, I started to support Gradle. So this example is built directly from an example of libgdx and Spine, and it just defines a desktop main, and then we include libgdx libraries, and then here I define a JTRansc library that will override these ones. So I can call this example with Gradle run. I'm going to run with the TeaVM, and it failed. No. Okay. No. Okay, so no demo here. Well, so I have another example. Here. And we have, it should be here. Let's try. And here we have a slots game that we have ported, running using JTRansc, and it works on HTML and Flash. And of course, C++, Android, and iOS. The project is 100% open source, and contributions are always welcomed. Pull requests, back reports, suggestions, documentation, and so on. So that's it.
If I understand correctly, you generate the Haxe syntax from JVM stuff, right? You go through the syntax level of Haxe, so you generate Haxe code. Is that true?
What? Can you repeat?
You generate Haxe code.
Yes.
So syntax in Haxe.
I'm generating, JTRansc is the source code of JTRansc is writing in Kotlin, and it transforms bytecode into Haxe code, source code.
Is there anything in Haxe syntax that you feel is missing? And
for example, when we're looping, in some case I will need breaking several loops, and you can't right now. You don't have labeled loops, Also, one thing that would be great is a line preprocessor, so I can, so when generating source maps, I could just tell which JavaScript or which Java or Kotlin line it is. Right now, I have two source maps. One for every Haxe file, it is generated a map file that indicates the association, and then there is the JavaScript source map that, so with a couple of jumps, I can. The rest, I think, Haxe is predefined.
It's an amazing project. I'm really impressed.
Thanks.
And I see that you can reverse, like from Java, you can make a Haxe code as previously. I think it's amazing. But I see that you made it on pre-configured Java files. Have you tried to take some larger systems and implement your method to perform a Haxe code? I know, Apache server or something like that.
No, we have tried with our code base and it works, but we didn't try it yet with something like that. Probably it won't work because it doesn't implement socket servers and that kind of stuff.
Have you tried? Is this on? Okay. Have you tried to compile back to Java and see how it performs?
It doesn't work. Right now, Java Haxe target doesn't compile generated code, and the same goes for C#, I think. But it works with C++, JavaScript, and some others. But it fails on some targets.
I'd be interested to know what's...
Okay.
All right. Thank you, Carlos.